Our next speaker is Brandon Henning. Brandon is a principal structures engineer and inspection leader from Nevada DOT, and he's going to be talking about unmanned aerial systems for bridge inspection. Please welcome Brandon.
Thank you, guys. I'm in charge of the bridge inspection program for the state of Nevada, and my presentation is going to be on using a drone for the Callahan-Tillman structure that is shared between Nevada and Arizona. And this is the bridge that overlooks Hoover Dam. The Callahan-Tillman structure is a concrete arch bridge with steel box girders. It's a total of 16 spans, and it's 1,060-foot open span arch main span, and then 806 feet of pier supported approach spans. This is inspected on a 2-year cycle. It was opened in 2010, so it's a fairly new bridge. And currently, Stantec Consulting is our consultant that helps us with our inspections and with our rope climbing of this bridge. We do not currently have anybody at NDOT that's SPRAT certified, so they provide all the SPRAT certified people for the inspection of this bridge. So first, I'm going to kind of go in what our normal inspection is on a 2-year cycle without a drone use. It's normally a 2-week inspection, 1 week per direction. These are 2 bridges, north and southbound. We use 2 under-bridge inspection vehicles. We have an A62 and an A75. Our policy for this bridge and a couple of our other signature bridges that we have, we need to have both trucks operational at the same time for the inspection to continue. We contract out our traffic control, which is normally about 3 people, and then we bring in our NDOT maintenance staff that we have CDL license and have driven our U-bits before, just to assist us because it's long days moving the trucks and then operation-wise, and this maintenance staff can't operate the buckets and deploy climbers and stuff. So, and then we have 2 internal and special equipment operators, and these guys drive our trucks all over the state and operate the U-bits, the buckets, and everything. So, and then normally we bring along 2 of our NDOT bridge inspection staff to either assist with the ground level inspections, or also they are also trained on operating the U-bits. So, I don't know if you've operated a U-bit, but sometimes when you're spending all day pushing that lever down and doing all the controls, your legs get pretty tired. So, and then also allow for some bathroom breaks. And then we have between 8 to 10 SPRAT certified climbers, and that's currently Stantec, and 2 level 3s. So we always have a level 3 on top of the deck. Traffic control, this is I-11 or US-93. The northbound direction has a sidewalk that everybody uses to take videos and pictures of the Hoover Dam. When we are northbound, we have to coordinate with the Hoover Dam security to close off that access to that area, so we don't get pedestrians going underneath the U-bits or holding up processes with our climbers. And then we have 2 crash attenuator trucks that we have behind all our U-bits. And then we use NHP just to kind of keep traffic slowed down. The inspection process is, the deck inspection is performed on the deck from the closed lane. And the superstructure for the steel box girders and the bearings are done with our U-bits. And then the open spandrel arch span is inspected with the combination of the U-bits and climbers. And the substructure is for the piers and abutments of the approach spans is inspected by a combination of the U-bits and the rope access. So here's some pictures from our rope access, some climbers, and then our U-bit deploying one of the climbers up there, the top right. So the U-bits are used to access our steel tub girders and attach to the anchors for the climbers. And then climbers will inspect the piers and the arch, and then once they're done, we retrieve them. Some of the difficulties, it seems like this inspection, we always have a U-bit that breaks down. Being our policy is to have both U-bits operational at the same time. If one goes down, we got to pull everybody up and inspections stop. This canyon has some high winds, so this can affect our operations with our U-bits and then also with the climbers. Luckily, there's the canyon with the approach spans. We can kind of hide from the wind pretty good, so that helps a little bit. So in 2019, or I guess 2018, I asked Stantec to contract or kind of get some quotes on having drones for this inspection. and just to see how it would help us in the future. The original plan was to have the drone and the U-bits and all the climbers there the same week. With our luck with our U-bits, well, one of our U-bits was in the shop and wasn't ready to go. So I ended up proceeding with 1 week of just drone work that didn't require traffic control, because we could access some shoulders and then to get underneath the bridge to deploy the drones. And then we were still going to have our 1 week of full access inspections for everything that the drones didn't get, or stuff that we needed to look at that was concerns from the drone inspection. So, and we still have our 2 U-bits, pretty much the same for the NDOT and the traffic control staff, but we do have a little bit less from the Stantec personnel because we're not climbing as much in those 2 weeks. So this was kind of the requirements for like the drones, and some of these pictures off to the right are the pictures that we got from the drone. High resolution color video, still color images, video images 1280 by 720, image resolution 20 megapixels, high resolution cameras, should have the ability to look in all directions, so we were making sure that it could look up at the same time. Final output in JPEG or MP4 format, and then we didn't want to have any specialized software that we needed to install on our computers to look at the stuff. So some of the requirements in the green up here on the right is kind of the approach spans that we had them use the drone on. And so we had them slow pan and still images at 5-foot intervals with overlaps. And so that was the full length of the exterior edge of the deck, the full length of both vertical faces of each girders, and the full length of the deck underside, interior bays, and bottom flange of the girders. And then visible vertical surfaces, all faces, pier seats, caps, shafts, and then high resolution still images of each bearing. Some of the requirements, the FAA license, certifications, qualifications of the pilots, insurance liability, project confidentiality, and then past experience with bridge inspection and UAV use. Being this is right next to the Hoover Dam, we had to get the A-OK from the Bureau of Reclamation and Hoover Dam Security to do the drones. As you can see, that guy had some fall protection because we're right on the edge here of the slopes. There's enough area to kind of fly underneath. We had a rope attached to them. Now, we did have an iPad that not only the operator, but an assistant could look through and see what was going on. So I was able, when I came down for this, I was able to look at the videos and everything. If we would have had it all set up for the inspection, we would have had like a truck set up on top of the deck with like an easy up just to be able to look at the video, and then we can eliminate piers or and columns that we don't need to look at. So this is the video that we're getting from the drone. Stantec took this basically from the time we did the drone to the time we did the next inspection. Once the trucks were ready, it was about a month, and Stantec took the video from ARE and gave us it told us basically eliminated columns and piers that we didn't need to go actually climb just from the video and experience from the previous inspections that they've climbed these piers. But in the end, it did shut down, it shrunk our inspection down by a week. So instead of a 2-week inspection like we normally have, yes, it was 2 weeks, 1 drone, but we didn't have all the NDOT and Stantec personnel out there for 2 weeks. Some of the difficulties, like I said, we still have the wind with the climbers and the U-bits. The wind can affect the drone operations. I think we had a couple days where we were able to work in the morning and then they had to shut down. So, but they were still able to get it done within a week. So that was good. U-bit breakdowns. As the case with our U-bits for whatever reason on this bridge, even in the 1 week we did the inspection and brought out the whole team, one of the U-bits broke down on, I think it was like a Thursday morning, and we were down the entire day, but we were able to finish all the work on Friday. So it was it's a little frustrating, but I was like, okay, well, we'll deal with it. And this is a comparison of cost. So we did the drone in 2019. Then we did a regular inspection without a drone in 2021. And so it was about $100,000 worth of savings. Now, I do have the 2021 is still at the height of the pandemic, so people were driving, our consultants were using separate vehicles, one person vehicle, so It was a little bit more expensive because of COVID-19, and then this 2021 inspection, we also had a U-bit breakdown. That put us, we had to demob the entire team and come back a couple weeks later to finish the inspection. So benefits, decrease the cost of the inspections, decrease traffic control restrictions, so not as many safety hazards with having people out there for 2 weeks. On my end, scheduling other inspections, it saves me a week in the inspections, especially if it's a heavy period. So I want to do a special thanks to Stantec Consulting, Nick Ciafretti, Ryan Nadlick, and Michael Marshall, and ARE, Sam Johnson, Nick Ray, and Dave Anderson. After I did the test in 2019, I knew our locations division had a drone, but they were mostly doing it for survey and public relations. So in 2020, I contacted them and said, hey, well, let's see what you guys can do. And come to find out, they cannot go underneath the bridge because they need to keep satellite communication the entire time. It doesn't really work. We got some video and everything like that, but it wasn't as high quality as what we were getting from ARE. So here's some pictures of them flying of a bridge in northern Nevada. As you can see, it's in the height of the pandemic, so we're wearing masks. And then this is a picture of them flying. If you look up in the right-hand corner, UBIT is inspecting at the same time, but they could get a little bit closer, but that is about as close as they were able to get, so that was kind of why the quality wasn't as good. Moving forward, we kind of developed like a plan that's going to be every 4 years we're going to use drones, especially on our signature bridges. So the Ocala and Tillman is the one we just showed you, and then if you've ever been in northern Nevada, we have which we call the Galena Creek Bridge, which is up at the right-hand corner, is a similar bridge, but it's all concrete, and we can access pretty much the whole bridge, but columns are really tall, so there's only so much we can get. So we were going to use a drone to look at the outside of the columns. We can look at the inside, we just can't look at the outside. There's a few bridges throughout the state that are really long columns, so we're planning on trying to arrange it with our access inspections to get those areas that from the ground and from the UBITs you can't see. So another project, this didn't plan on this or anything, this Manam Applications from Israel and Avasite, who's based out of Vegas, contacted us. It was 2019, said that they got this Israeli U.S. Bird Foundation grant to develop some bridge inspection software for drones and using 3D models. I guess they're gonna be presenting at the TRB if you guys go this year. So, and I believe they're gonna be showing the Ocala and Tillman Bridge, because that was, they asked them about middle of 2020 if they could go to the Callahan-Tillman Bridge, and we ended up getting it January 4th of this year, just so the people from Israel could get to the States. Before that, it was a little bit harder during COVID. So they have this software which basically creating an automatic flight mission, or they survey it and keep it for next time, so it could automatically fly the same routes as it did the previous inspection, and then they do the 3D modeling. And then have a bridge defect analysis. Right now it's a manual defect analysis, but they're working towards where it's automatically done by the computer. So, and then they developed like a software type, which they call the 3D BIA. And this is kind of just a picture of the software that they gave us as like a trial basis, because we worked with them and allowed them to kind of come in our state and take develop their product. And as you can see up, there's a SPAL here, so this is the actual picture, and then this is their 3D model with the SPAL. And then here's the contacts for Manam and Avasite. That is all I got.
Thank you very much, Brandon.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.